So permutations with cases, like I mentioned before, sometimes you can't count things all at once. So you have to count them in separate little bits. And once you've counted them in those separate bits, you can add up each of them together to get the total. So here is a simple example where it says at most 3 different digits. So we could have 3-digit numbers, 2-digit numbers, and 1-digit number. Now when we're working with a cases question, as far as our explanation, we write out, okay, I'm going to count my first case and give a brief description of what that case is. So for case 1, I'm going to count the 3-digit numbers first. That would be 3 spaces. Are there any restrictions on any of these? Right, the first one is not 0. That looks like noto. I'll try that again. Oh, that's a bad. That's a nicer one. The squiggly brackets, terribly frustrating. So hard to make a nice squiggly bracket. The one on the left, disastrous. Oh well. So it can't be a 0 to start. 9 choices. How many choices for our next one? 9, because now 0 could get put back in, and then 8 for 648 total. So we counted all the 3-digit ones. What's going to be our case 2? 2-digit numbers. Any restrictions on our 2-digit number? Can't be 0 to start with. Whoo, that's a pretty one. Oh, those are nice squiggle brackets. So there's going to be 9, and then 9 again for 81. And case 3, single-digit numbers. How many are we going to put in that space? 10. Everybody okay with 0 being a number? So if we add these all up, it's 739. So for this one, because we were doing single digit, double digit, and triple digit, it made sense to break it up into cases. More often, our case questions are a little bit disguised. No repetition. Now we're using 1, 2, 3, 4, or 5. It has to be greater than 300 and even. So what's generally going to happen is you're going to try to solve this all at once. So you're going to draw your spaces out, and you're going to say, well, if it's greater than 300, this has to be a 3, a 4, or a 5. And if it's even, this has to be a 2 or a 4. And you might even go so far and say, well, I have 3 choices here for that restriction, and then I have 2 choices here, and then I've used up 2 numbers, so I have 3 left. And you might quickly write the numbers down. But the question is, well, if I have 3 choices for that first restriction, it could be a 3, a 4, or a 5. What happens if I pick the 4? Then this is a 1. But if I pick the 3, then this is a 2. But if I pick the 5, it could also, it can stay at 2. So how do we do this? We don't know what number to put in the end. So when we have this, whenever we have a restriction that overlaps in 2 different places, we break it up. And we break it up in cases so that there's not an overlap. So the 4 is a problem. If I wanted to separate things so that that 4 isn't a problem, I can say, well, let's make my case 1. If I start with a 3 or a 5, I make my first digit a 3 or a 5. There'd be 2 choices there. Can you see that in order to make it even, I now have no problem here? This can be 2 or 4. And there's no overlap in those restrictions. And how many choices would there be for the middle number? 3. because you had 5 numbers to start with. You've now used up 2 of those numbers. Multiply all those together, and there's 12 ways. So that counted all the ones that started with a 3 or a 5. What numbers haven't we counted? Case 2 starts with a 4. So as you're going through your cases, you'll often ask yourself, what haven't I counted yet? Or have I finished counting? Have I categorized everything? So starting with a 4, well, if this has to be a 4, what's going to happen to our last digit? It has to be a 2. We've used up those 2 numbers, 3 choices left. And we get 15 in total. When you're deciding to break up your cases, you often have more than one option. I've seen people do this question where they break up their first digit into 3 cases. I'm going to start with a 3. Then I'm going to start with a 4. Then I'm going to start with a 5. And if you add those up, you'll get exactly 15 again. We could also do this same question and break up our last restriction into cases. Notice our last restriction to be even is either a 2 or a 4. And so we could make case 1, let's end with a 4. And if I end with a 4, how many options do I have for the first number? Right? The first number can be a 3 or a 5. 2 options, then 3 left, which gives me 6. What haven't I counted? Ends with a 2. One option there. Then my first option can be a 3, a 4, or a 5. 3 options left. 9. Add those cases together, and notice we get the same answer. So depending on how you break up your thinking, might give you different answers along the way, but when you add up your cases in the end, you'll get the same answer. So another typical type of cases question is counting how many numbers are greater than a certain number, or how many numbers are less than a certain number. And for these questions, what I like to always make my case 1 is what would guarantee my number would be greater than 232? If I start with a 3, a 4, or 5. If I start with a 2, I'm not guaranteed that it's going to be greater. But if I start with a 3, a 4, or a 5, that will count all the numbers in the 300s, 400s, and 500s. And then can you see that there will be no restrictions on the next 2 digits? So if I start with a 3, 4, or 5, there's 4 numbers left that can go here, 3 numbers that can go there, 36 in total. What haven't I counted? Case 2. I haven't counted any of my numbers in the 200s. But if I start with a 2, can you see that I now have restrictions on my second number? So if I start with a 2, again, using the same idea that I did with case 1, now what could I do to guarantee that it's bigger? Start with a 2, then have a 4 or a 5. So now there's a restriction on this one as well. 2 choices. And this will count all the numbers in the 240s and all the numbers in the 250s. And there would be no restrictions on the last one. Case 3, so you can see where this is going to help us with that question number 15 where it said greater than 5,600, right? Case 3, what haven't we counted? We haven't counted any of the 230s. So if we start with a 2, and again, it's very important that we write out a little explanation underneath where we're getting our numbers from. If I start with a 2 and then a 3, what are my choices for the last number to be greater than 232? 4 and 5. And if you don't write out the numbers underneath, you might think, oh, if I have a 3 at my last digit, 3 is bigger than 2. Why can't I put a 3 here? Because you've used up the 3. So by writing them out, it also helps you realize which numbers you've used up and which ones you have left. So we have two choices here. Add 36 plus 6 plus 2 together, and we have 44 in total. Okay. That is where we are going to end. And now, permutations 3 and 4, we are going to work on.